A 1 nanometer electron beam lithography (EBL) device is theoretically possible, but extremely challenging and not yet widely available for commercial or even research applications. While modern EBL systems can achieve spot sizes down to 2 to 10 nanometers, achieving true 1 nanometer resolution requires specialized techniques and equipment, like aberration, corrected scanning transmission electron microscopes, STEM. These systems are not standard and are found in specialized facilities. Here's a breakdown of the challenges and possibilities. Challenges of 1 nanometer. EBL. Beam size and stability. Traditional EBL systems struggle to produce and maintain a beam with a diameter smaller than a few nanometers. Proximity effects. Electrons scatter within the resist and substrate, causing unwanted exposure and blurring of patterns, especially at smaller feature sizes. Resist limitations. The most common resists, electron-sensitive polymers, have resolution limits around 10 nanometers. System complexity and cost. Aberration-corrected stems are extremely expensive and require specialized expertise to operate. Approaches to achieve 1 nanometer, EBL, aberration-corrected stem. These microscopes, designed for atomic resolution imaging, can be adapted for lithography, offering the potential for 1 nanometer resolution. Specialized resists. Some studies have explored using materials like Al-F3 and Al-2O3 that can be directly sublimated with electron beams, allowing for the creation of 1 nanometer structures. Quantum mechanical effects. Some research explores leveraging quantum tunneling and other quantum phenomena to achieve atomic scale resolution, but these are still in early stages of development. Current status. While 1 nanometer features have been demonstrated in experimental settings, they are not yet routine or practical for most applications. Commercial EBL systems typically focus on achieving sub-10 nanometer resolution for various applications, including nanoelectronics, photonics, and biotechnology. Future research aims to overcome the limitations of current EBL and develop more practical and scalable methods for achieving 1 nanometer resolution. Costs of 1 nanometer electron beam lithography. Devices AI Analysis Copilot, a 1 nanometer electron beam lithography (EBL) device, is more of a cutting-edge research tool than a commercial product, and its cost reflects that rarity and complexity. Here's what we know. Standard EBL systems with sub-10 nanometer resolution typically range from 1 million to 5 million US dollars, depending on capabilities, throughput, and automation. Aberration-corrected scanning transmission electron microscopes, STEMs, which can be adapted for 1 nanometer EBL, are even more expensive, often exceeding 10 million US dollars, and are usually found in national labs or elite research institutions. These systems also require specialized facilities, expert operators, and custom resists, adding to the total cost of ownership. The cost isn't just about the hardware, it's about the infrastructure, expertise, and precision engineering needed to push atomic scale boundaries. Cost of 1 nanometer electron beam lithography facility. Building the infrastructure to support a 1 nanometer electron beam lithography (EBL) system, especially for a self-replicating nanofactory, goes far beyond the cost of the device itself. Here's a breakdown of the major components and their estimated costs. 1. Facility requirements. Cleanroom construction, class 100 or better, $2 million to $10 million, depending on size and location. Vibration isolation systems, $100,000 to $500,000, electromagnetic shielding, $50,000 to $200,000, environmental controls, temperature, humidity, air purity, $500,000 to $2 million. 2. Power and cooling systems. High voltage power supplies for the EBL system, $100,000 to $300,000. Cooling systems, liquid or air-based, $200,000 to $1 million. Backup power and surge protection, $50,000 to $250,000. 3. Material handling and safety. Gas and chemical delivery systems for resists and substrates, $100,000 to $500,000. Waste management and filtration, $50,000 to $300,000. Safety systems, fire suppression, toxic gas sensors, $100,000 to $400,000. 4. Personnel and training. Hiring specialized staff, engineers, operators, maintenance. $500,000 to $2 million annually. Training programs and certifications. $50,000 to $200,000. 5. Computational and control systems. High-performance computing for pattern generation and simulation. $200,000 to $1 million. Software licenses for EBL control and design. $100,000 to $500,000. 6. Ancillary equipment. Scanning electron microscopes, SEM, for inspection. $500,000 to $2 million. Atomic force microscopes, AFM, for surface analysis. $200,000 to $1 million. Nano positioning stages and robotics. $300,000 to $1.5 million. Total estimated infrastructure cost. $5 million to $20 million plus, depending on scale, location, and whether the facility is built from scratch or retrofitted.